So there are different ways to get to the concept of synthetic population, and for us the way to get there is to start from the simplest definition of what is a contagion process. That is basically, if you strip to the bare bone the elements of the system, you have individuals that are like particles that diffuse on a network. And because of the interaction on the networks, they change state, and that can model different kind of contagion processes, ranging from disease models to knowledge and influence and habits, behavior. What happens is that to this bare bone model, we need to add several layers that define where the particles are, what are the attributes of those particles, and then you start to add age, gender, kind of mobility, and so on and so forth. So all those attributes then start to create a kind of synthetic world in which the dynamic of interactions, the way the particles and at this point the individuals interacts, define the contagion unfolding. And basically we get to the construction of the synthetic population by adding layers, and that's what is our approach in two senses, in a nutshell. What happens is that adding elements to the synthetic world and adding attributes to the elements of the synthetic world, the particles, that becomes, rich in attributes because represent individuals, and the fact that the system is embedded in geography, and the fact that the interaction that we consider and the kind of mobility becomes very complex, well, that becomes a computational challenge. You need a lot of CPU, you need a lot of processing time to make even a single realization of the system. But actually, a single realization of the system is just one stochastic realization of the many possible ones, and so you have to repeat this process multiple times. That corresponds on one side of the need of high-performance computing to carry out the large-scale simulations. That means to create a lot of instances, a lot of possible parallelization schemes to increase the computational gain and achieve higher performance. But at the same time, also, the more performance you achieve from the large-scale simulations implemented on high performance computing, and the more you generate a large amount of data. And that means, that you need high-performance data analysis. The more data we have, the more sophisticated are the models, and the more we will need computation, high-performance computing, and the more we will generate large data sets that need high-performance data analysis.